Hello and welcome to Team PikaWatts demonstration video for our metal detecting module. We are a senior design team sponsored by Dennis Height to create a new module for the Modular Remote Vehicle. But firstly, what is the Modular Remote Vehicle? The Modular Remote Vehicle, or MRV, is a device created by Team Rhodium in the mid-2010s as a vehicle for the University of Alabama and Huntsville's outreach programs. It has since become a torch that is passed down to a new senior design team almost every year. Since its creation, it has seen many changes, the largest of which is the addition of the module port, allowing for new modules to be easily added, as well as a chassis update and a case revamp. The main mission of Team PikaWatts metal detecting module is to accurately detect metal on or shallowly under the ground. A secondary objective of Team PikaWatt was to create a module that was aesthetically pleasing and interesting to look at. To complete this goal, Team PikaWatt chose to use an inductance to digital method of detection. The method utilizes two coils simultaneously. The first coil, or the control coil, generates a changing magnetic field and records its frequency. Then, the second coil, or sensing coil, generates its own changing magnetic field. The secondary field generates eddy currents in a conductive material nearby. These eddy currents oppose the original magnetic field and essentially create a change in inductance, which can be measured as a change in frequency. The control frequency and the sensing frequency are then compared to achieve an analog output. This output is then digitized and read through I2C. The MDM device can be easily connected to the MRV using the MRV's built-in module port. The MDM has two methods of notification when a detection event happens. The first being a 100 decibel 2 kHz tone that is played, and the second being 3 flashing LEDs on the case of the MDM. During a detection event, if one coil has detected metal, the tone and lights will blink. This indicates the metal being to the left or right of center. In the event that both coils detect the object simultaneously, the tone and lights are solid, indicating the metal is directly center of the module. Here you can see the module being tested in the MRV's module port. Here we are testing if both sensor coils are operating correctly, and if the output peripherals are correctly indicating if one or both channels are detecting a conductive object. This test's primary purpose was to find the optimal sensor values when taking the MRV's electronics into account, as well as the distance to the floor. During this test, we were also discovering if the MDM had any issue riding on the MRV and the module port. For our second test, we were testing to see if the MRV's capabilities were at all affected by the MDM's presence, as well as if the MDM would operate while the vehicle was moving or after having moved. This test was a success, and gave us hope for the future exterior excursion testing. The interior excursion testing was mainly done to ascertain the ability of the MDM and MRV to work as a single unit, and to detect any faults before moving to the final stage of testing. Here you can see the success of this test in that the metal was detected, no false detections occurred, as well the MRV was able to operate at full capacity. Finally, we arrive at the exterior excursion testing. Here you can see us detecting the test targets in a grassy environment during a warm day. This test was done to see if the module would have any adverse reactions to the heat or driving environment. We were also testing if the metal would still be detected in the uncontrolled environment of the outdoors. This was a resounding success, with no major part breaks, accurate metal detection, and no false detections. We also were able to prove the MRV was able to operate at full capacity even with the outreaching sensing coils. Overall, the MDM project was a successful project that allowed our team to experience the typical engineering workflow while still being within the academic environment. All the team members learned valuable lessons, and we hope that the MDM can go on to inspire the engineers of tomorrow.